Hello and welcome to Gadget Joe, and today we take a look at yet another offering by Sabrent. Sabrent are a very promising name in the storage industry and have been consistently knocking out some fantastic products that combine both performance and affordability. We had our hands on a 2TB Rocket Q late last year and we were left impressed with what we found. You can check out this video by clicking the pop-out link at the top or linked in the description below. With that in mind, today we have the Rocket Q4 to test out. Upon first glance it looks very much like the Rocket Q, just with a different colour. And that's fair to say, but as far as NVMe drives go, the design is always going to be relatively limited. Before we get to the testing and benching of the Q4, let's take a look at what you get in the box itself. With ours you get the heatsink and the drive itself. The box for the Q4 is small and compact, very similar to the Rocket Q. Inside you get a gold metal tin that is hinged via a sticker on the side. Inside you get a user manual, a foam insert and then a drive itself. It carries a white and gold aesthetic. It is a 2280, which means it's 22mm wide and 80mm long. It's also incredibly compact with the NAND memory packages on both sides of a black PCB alongside the controller and DRAM chip. We'll look at the specs a little bit more in detail shortly. Now let's move on to the heatsink. The heatsink is not an expensive addition, but it is made for its intended purpose and fits in nicely with the Sabrent theme. The box is small and well laid out with mounting screws placed in the middle and an included screwdriver. You then get the heatsink itself and another foam sticky heat pad. The heatsink is relatively compact but still bulkier than the standard heatsink you would find on your motherboard. It is all aluminium machined and looks fantastic. It comprises of 3 heat pipes going across it too. There is also a mounting bracket that houses the drive and allows it all to be fixed together. Mounting the cooler to the drive is relatively simple. Lay everything out like this. On the casing itself, it comes with an included heat transfer pad labelled A. There is one labelled B, but that is used if the drive is single-sided. Ours is a double-sided unit. Simply peel back the tape and place the drive into position, lining it up with the mounting screw holes. We then take the heatsink and remove the peel from this pad. Secure it into position in the correct way and adhere. The mounting screws will then line up, and using the included screwdriver you can poke the screws out and secure it in. And that's pretty much it. As far as mounting into the system, you remove the existing heatsink and attach the drive into the socket and fix the mounting screw into place as you would normally, and you're good to go. In a moment we will get to testing and benching the Q4, but before we do that let's take a look at the specs of the drive. The Q4 comes in 3 different sizes, from 1, 2 up to a 4TB. We have the 2TB here. All the Q4s are PCIe 4 compatible and utilise NVMe 1.3. They will of course work in PCIe 3, but you'll see a difference in performance, but it doesn't necessarily mean you're limited to the newer motherboards. The memory modules are Micron 96L QLC with a rated sequential read of 4800 megabits and a read of 3600 megabits. The Q4 uses a Phison E16 controller, which is historically the first PCIe 4 NVMe SSD controller to hit the market. The E16 handles processes very well and is built using 2 Cortex R5 CPUs on a 28mm process node, and it operates very well with the firmware for improved performance and efficiency. The Q4 does feature a relatively limited write cache, however, that spans 1/4 of the available capacity. So on ours you can write up to 500GB of data before the performance starts to slow. Sabrent have tried to combat this by including a fully dynamic write cache that allows it to recover quickly by dumping some of the cache files to try and maintain speed and performance. Now we get to the real reason you're here, and that is the results of our benching. For our setup we use the 2TB Rocket Q4 with the heatsink on an MSI X470 Gaming Pro Carbon Wi-Fi with a Ryzen 7 3700X, Radeon RX 5600 XT and 16GB T-Force DDR4 RAM. We ran the tests in the same way we ran them for the Rocket we recently reviewed, and have put the results from the Q4 compared to the Rocket, a T-Force 128GB SSD and a 2TB hard drive to get a feeling for the performance ranges across the board. It's worth noting now that we tested the Q4 in PCIe 4, so if you used it in PCIe 3, it will likely yield results more on par with the Rocket scores. Let's start off with Crystal Disk Mark. This is generally the most used software for benching storage. The figures instantly are clear to see. We ran the test 5 times on each with a 1GB file test size, and the Rocket Q4 scored highly on this with a 4980 read and 3587 write speed. A huge improvement over the Rocket Q, which produced a highly respectable sequential score of just under 3500 read and a 3000 write. Random read time with a 4KB block size produced an impressive 1434 read and 1538 write score. The difference of the same drive on PCIe 2 is quite drastic by being just under a third of the total scores of the PCIe 3 test. However, this is still a major improvement over the standard SATA SSD read and write scores. The hard drive scores are absolutely abysmal compared to all, however for storage that's more than adequate. We then used Atto's Disk Benchmark for some slightly more comprehensive and stress-heavy results. We set it to 512 bytes to 64 megabytes with a 256 megabyte file size across all tests, and the Q4 yielded a maximum score of 3.37 gigabytes read and a very impressive read score of 5.24 gigabytes. This was a true testament to the capabilities of PCIe 4, and the results are drastically higher than the Rocket Q PCIe 3 test, which gave a maximum score of 2.79 read and 3.23 write. But you can see the variation of speeds across different tests. The read scores were relatively consistent, staying at around the late 4 to early 5 GB range over the 2 to 3 GB range of a Rocket Q. Whilst the write speed fluctuated wildly on the Rocket Q after a consistent reading of up to the later 2 GB range, up to the 1 MB input point, in which it went as low as 200 MB up to around 1.5 GB. The Q4 stabilised at around the 256 to 512 MB range, at which point it kept a relatively tight pattern as it went on. When used in PCIe 2, however, it yielded some very different results. Granted, the scores were not quite so high, which is to be expected. There is a lot more consistency this time round. The scores increased to the high 700 to 800 megabytes in read and write, but they kept very consistent across with no real visible dips at all. The story is very much the same with the SATA SSD and hard drive, with consistent but much lower read and write speeds. Generally, they don't recommend using Atto for SSDs as it can be known to reduce the lifespan. However, I wanted to put it under some real-time stress testing to see how it handles it, and as you can see, that it did struggle on some areas. However, the overall consensus is that it performed well considering its price point. We then used ASSSD Benchmark to give another reading of the sequential and random file read and write times. ASSSD is older software, but is often very reliable and shows the elapsed time and then gives it a final score. Naturally, the higher the score, the better. This software also works well with NVMe testing. On PCIe 3, we got an overall score of 6368 with a higher write score than read, which based on the testing so far would show that it might handle random sequences and blocks better than a traditional SATA SSD. This could also be down to the PCIe 4 technology. On the Rocket Q using PCIe 3, it gave us similar trends of scoring, however it gave a lower score of 4541. The Rocket Q on PCIe 2 scored 1874 with a higher read score this time around. Again, something that is consistent with PCIe 2 performance. The SSD came in with 542, which is a staggeringly lower than the Rocket Q on both platforms, and the hard drive didn't even finish the test, so we'll leave the conclusions to that one open. Now we move on to one of my favourite forms of testing with Anvil's storage utilities software. Again, it's an older suite, but it remains unchanged for good reason as it just works well. What this does is very similar to Crystal Disk and ASSSD. However, it pushes the workload a little further by providing more test subjects to the drive. It also then records the response time for each test, which then equates with the other results to give it an overall score. This is where things get a little bit interesting, and the results could be down to any factors from limitations of PCIe 4 or the drive itself, as the Q4 performed fantastically well with an overall score of 15,000. However, when you look at the read score, it sits at just under 5,000, whereas the Rocket Q actually outperformed this by around 250 points. The write score gained back the advantage for the Q4 with a substantially higher score of over 10,000 compared to the Rocket Q's 6,800 score, with the majority of the read and write tests being carried out in under 0.01 milliseconds, when on PCIe 2 the performance is generally halved on this test. However, it's still a very respectable score. The SSD and hard drive gave results pretty much where you'd expect them to be. The final test is HD Tune Pro. The main benefit of this benchmark tool is that you can see the real-time scores and access time as it is tested, which gives you a better reading of the range. Often you are given a minimum score and a maximum score, and it is often difficult to tell where the drive actually tends to perform in terms of whether it spends more time at the lower or higher end of that score. The Q4 scored very well in this test, with a minimum read score of 926, topping out at just under 2,400, with an average of 2,000. The similarities that show across the NVMe drives is the tendency to fluctuate wildly with a large low to high range, with the Q4 showcasing a range of up to 1.4 gigabytes, which is a huge difference. However, the Q4 scores well even at the lower end, and the access time of just 0.023 milliseconds is beyond impressive. The scoring of the Rocket Q on PCIe 3 shows a maximum of 1412 and a low of 656. The suite determines an average of 1168. However, you can see again that it does fluctuate very wildly during testing. The consistency is generally within a range of 500 megabytes, consistently spiking and dropping. The access time is very low, coming in at just under 0.04 milliseconds. Overall, the score is good, but it does fluctuate a lot within the range. On PCIe 2, the fluctuations are there, but they are much tighter ranged. However, the access time here is much more sporadic. The SSD, however, yields a very different result, with a massively inconsistent pattern, dropping to as low as 24 megabytes at points, and peaking at 417. The access time, however, is relatively steady. When it comes to the hard drive, the rate is more consistent here. It offers very little fluctuation. However, you see the rates drop as the file size gets bigger, which in turn sends the access time higher. Overall, the Q4 has left me feeling very impressed with its high speeds in both read and write scenarios across all the tests. At times it did fluctuate wildly, and that does seem to be a common scenario with most NVMe drives as such. However, the move to PCIe 4 is definitely a very welcome one, as the results are clear to see. We are not talking about a slight increase in performance and abilities, but a significant one of around a 30% increase over PCIe 3. Naturally, the Q4 was always going to outperform the PCIe 3 enabled Rocket Q, but it was very interesting to see just how much so. And it was also very good to put such similar drives to extensive testing to see the fluctuations between the results. The Q4 is a fantastic drive and is definitely well worth the money, as it is very competitively priced to boot compared to a lot of its closer rivals. The included cooler does seem a tad overcompensating and a little bit obnoxious with its large size, but it performs well and is reassuringly well made. The only real downsides to the Q4 in my opinion is that low write cache, but in testing it seemed to do a very good job of resetting itself and dumping the cache memory to maximise performance. It might just mean that if you're a heavy user of your system for work, then you might need to power down your system at the end of the day. But then that's common practice amongst the majority anyhow, so it's not really a real issue. I would certainly recommend the Q4 if you're in the market for a new PCIe 4 NVMe drive, especially if you're on the lower end of a budget too. As always, I will leave a link in the description below as to where you can get your own, and if you liked this video, leave a thumbs up and make sure you hit that subscribe button so we can keep growing. And that's it from me for now, and I'll see you in the next one.